Hello, I'm Philip Stoughton at Scoop Studio here at SMTAI in Chicago. I'm joined by Lenora Clark from McDermott, Chris Nash from Indium, and Phil Zarrow from ITM Consulting to talk about the automotive industry and some of the challenges facing the industry and the solutions that these companies have come up with. I'm going to just go along the line first of all, talk about what you see as some of the key challenges for the industry and the kind of products they're looking to you to provide to resolve those.
Okay, so as a chemical supplier in the electronics industry, we know that the automotive is seeing a massive influx of electronics into the automobile. A lot of that driven by autonomous driving. So a lot of safety systems coming in right now, high frequency and radar applications, which is a challenge from a PCB fabrication standpoint. There's new materials that come into play, so that's been a bit of a challenge. And also we see some challenges coming in from the e-mobility side. With electronic cars, this is high voltage, high power with a lot of miniaturization, so that creates design challenges as well as trying to manage heat in those situations. And I would think those are the two big things that we see.
Okay, and from your point of view, Chris, it's always been an industry that's demanded high reliability. What are they challenging you with at the moment?
Well, I think the challenges that we're seeing in high reliability right now are the alloy choice. So they have a lot of thermal cycling challenges where they're going from minus 40 to 125 or even higher now with minus 40 to 150 and minus 40 to 175. So we've developed some alloys like Indolite number 276 that is actually showing better performance than the Indolite alloy, which is really the industry standard right now. So we're really stressing the Indolite 276 at these higher thermal cycling temperatures, more stringent or more focused.
Okay, and Phil, when I look at it from your point of view, from a more holistic and more process-driven viewpoint, it's almost like two supply chains have collided. It's the old reliable automotive industry and it's the consumer technology that we now expect to have in our car. How do you deal with that from a process and line management point of view?
Well, it's very interesting, Phil, in the sense that among the automotive, both the OEMs and the CEMs that we've been working with, we see, I guess you could say they impress me as getting it in terms of from a process savvy, and best practice, embracing best practices. They get it, and they've gotten it for a long time. And I think it's driven by the requirement for high reliability as well as volume. So you kind of have the best of what the consumer and telecom has brought together, along with things like a high rel of medical and avionics. And so as a result, we see things in their processes. For example, cleanliness. I can't remember the last time I visited either an OEM or a CEM doing automotive that's not using gloves or finger cuts, which is a world-class best practice as far as any time before the board's been either finally soldered or conformally coated. Things like that. We see some of the highest efficiency in terms of line operation, balanced lines, very, very expedient setups, things like that, and great practice of continuous improvement. So yeah, the automotive people definitely get it and are constantly improving.
Yeah, and they're all driving in this same smart factory direction as well. Traceability has become a big thing. When you look at the products that you're building, are you building products specific for the automotive industry, or are you building them for automotive first and then they filter out to other industries?
I think that there's considerations for the automotive industry, like Chris was mentioning. Thermal shock is such a big aspect of their reliability that we're testing to another level, right? We're testing to a higher level. So I think that they are well aware of, we're using technologies now that were consumer driven, but they need to be a marked improved or the next step better. And so I think our testing has changed as a result of that. And with that, you have to have improved processes. So I think that the automotive space and what they're doing now is pushing the envelope a bit for us. Thickness of panels is another consideration, so that changes our development process a little bit. But I would say that, there's certain niche things that happen for automotive, but we need to be thinking as a chemical supplier on a broad spectrum, because our customers are not solely supplying to the automotive industry. But I think from a testing standpoint, things change.
Yeah, and that's true of the EMS companies that are in the industry as well, Chris. They're not just supplying automotive, they're supplying across the board, and if they've got a solution that works for automotive, it's going to work everywhere.
Yeah, absolutely. It's a bigger picture. It's the electronics industry as a whole rather than just the automotive sector. The automotive might be really leading the way in reliability, but similar to what the mobile has done with miniaturization in the past, right? So it's a really unique time, and it's good to see another sector of the market get so ingrained in the future of the marketplace.
It's moving fast. There's more and more electronics in the vehicle. You've been doing a lot in the area of voids, or the area of avoiding voids, not creating voids. Is that something that's been driven more by the automotive industry, or has that been a very general drive?
It's definitely a general drive, but the automotive customers they really care. They get it. They're all about reliability, and they understand that voiding and reducing voiding will help them improve their reliability. So it's something that they're just as interested in as the rest of the industry.
Do they have the same, I think you rate voids as kind of percentage of voided space or whatever. Do they have the same standard as everybody else, or a higher one? Or
everyone has a different
everyone
standard.
has their own.
Yeah, everyone has their own.
challenge.
But the automotive companies, we've seen less than 10% voiding for a lot of the automotive companies. Less than 5. Vacuum reflow is a big topic now, to try to reduce voiding to under 5% or under 1% in some cases. So I think it is the automotive that's really driving the lower and lower and lower.
Yeah. Okay. And Phil, from your point of view, obviously we mentioned Smart Factory. Some of the stuff that the automotive companies are doing that's Industry 4.0 is absolutely leading everybody else with data. Is that a big part of what you're seeing in the sector, this data-driven approach to manufacturing?
Yes, yeah, very much so. Again, they're on the vanguard, and again, based on both the reliability and the production quantities and schedules they have to build, tying in with the sophistication of what they're doing. So, yeah, things are very much data-driven these days. Where they're going, yeah.
Okay, last question to everybody. What do you see as the next big challenge for the automotive industry moving forward? What's gonna be keeping your R&D engineers awake at night for those automotive guys in the coming months and years?
I think the changes of materials and requirements for electronic cars is going to be a concern.
So it's when we get electric into the drivetrain and the material demands of that.
Higher voltage and higher power, and how to deal with that on a miniature level is something that we're all going to have to watch.
And Chris, from your point of view, it's all these technologies colliding, isn't it? It's high power, it's consumer electronics, it's automotive reliability.
Yeah, I think a lot of it is going to be electrical reliability as well. It's not just the alloy that we have to keep in mind. It's the SIR of the electrical reliability in the flux vehicle that's left behind. So are we going to see a resurgence in cleaning, or is it going to be a material that's going to improve the SIR performance?
Okay, and last word for you, Phil. What do you see as challenging the automotive engineers moving forward?
Mostly making these materials work with the processes and incorporating them at the production rates and efficiency that they need. So, for example, Chris mentioned vacuum soldering, and vacuum soldering by nature is not, in its present state, a continuous flow thing, because we obviously have to draw vacuum during reflow. So how do we make that work with the high production expectations we have? So little challenges like that. But everything's been invented, hasn't been invented yet, and we've seen a lot of other things, particularly from equipment, come out of the automotive. Selective soldering is a great example. It was born out of European automotive industry. So it just keeps getting better and better.
Yeah, all those designs, all those innovation are going to be pushed by various sectors, but it seems that automotive is one of the big ones. And as you mentioned, that's why this collaborative approach is important. They need to speak to process engineers, consumables companies from PCB and from assembly. Thanks so much, everybody, for taking part. Enjoy the rest of the show, and we'll talk again soon. Thank you.